If you are creating a scene with Unity's 3D cube and add textures, and you find that when you scale the cube, whether it's to make a floor or a long wall, its texture will be stretched. This problem can be solved by using shader graphs, and this is my personal method that you may want to apply later. First, let's understand a little bit of the principle. By default, in Unity's cube, the UVs of each face will overlap on the same area. To illustrate this, I'll export it and show you in Blender. You can see that the UVs of the Unity cube are different from the Blender cube, which has no overlap. We'll focus on the Unity cube. This time, I'll try to add a seamless image texture. You can download it from Polyhaven. To illustrate this, I'll duplicate it for comparison. When I scale one of them to x3y2z1, you can see that the texture pattern will be stretched to the changed proportions. This is because even though we have changed its external shape, the UVs are not scaled. So let's try to change the proportions of each UV to the proportions of the cube. Now we can see that the proportions of the texture pattern remain the same compared to the unscaled cube. Back in Unity, start with the usual steps to create a shader graph by right-clicking on an empty area of the project and selecting Create and finding Shader Graph and ERP and Lit Shader Graph and giving it a name of your choice. I'm going to call it Stonewall. Double-click to open the Shader Graph editor. Here you can see the master stack, which consists of the vertex and fragment parts. First, we'll create an attribute so that we can customize our shader by clicking on the plus sign. The first one will be of type texture. I'm going to name it texture. And by default, it's the original image I used in Blender that I've imported into assets. The next one is a float type or vector one. I will name it tiling to adjust the size of the texture. Let's prepare the texture map first. My first node is an object. To receive the scale value, the value is vector 3, so it must be split into RGB, where R is the x-axis, G is the y-axis, and B is the z-axis. Then we will create the width and length of each plane by using R and G to create vector 2 for the front and back planes, G and B for the left and right planes, and R and B for the top and bottom planes. Be careful about the order of RGB when inputting to vector 2. In this case, R will always input X and G must always input Y. The output of each node of vector 2 will be multiplied by vector 2 of tiling X and tiling Y. For scaling, I use the same value because I want to keep the aspect ratio of the texture. But you can create float attributes for both width and length. After multiplying, we will input it to the tiling slot of the tiling and offset node, and output it from here to the UV input slot of the sample texture 2D node. Then we will connect our texture to the texture input of this node as well. Do this for all 3 planes. The next part we will do is prepare the faces of the cube object. We will separate all 6 sides with normal nodes. Change the space from world to object, and then split by R for left and right side, G for top and bottom side, B for front and back side. For the left side of the object, we will connect the output R to the saturate node. But for the right side of the object, we will have to invert the output R with the negate node before connecting it to the saturate node. Do the same with the output Y and output Z. We will get all 6 sides of the cube. Okay, the next step is to get the textures of all 3 sides. The prepared planes are used on each side by taking the output of each 2D sample texture plane and multiplying it with our 6 sides. In this step, please make sure that the texture of the vector 2R, G plane will be multiplied with both saturate nodes of normal B. As for vector 2R, B, multiply with normal G, and vector 2 grams, B multiply with normal R. If you feel confused, try replacing the RGB value with XYZ. Finally, we can apply texture to every side of the cube. The rest is just to combine each side with that node, gradually combining each pair until all sides are complete. Then, take the final result and link it to the base color of the master stack. Our shader graph will be complete. The rest is the material creation step, changing its shader part to use our shader graph that can adjust the texture and tiling values. Try assigning it to the cube and trying to scale the different sides. Now our texture will not be changed in proportion. I hope this is more or less useful. Thank you for watching until the end. If you like it, please like and subscribe to this channel to encourage me to make more clips. Everyone's comments are meaningful and I hope to see you again soon. Goodbye.